Hello guys and welcome to today's video. So far we have solved the first part, which was to write the expression for Bessel's function of the first kind of order n. We've solved for the second part, which was quite lengthy but due to explanation. Okay, so to write the first few terms of j1 over 2 of x, and to prove that j1 over 2 of x is equal to root 2 all over pi x sine x. And finally we are coming to the last one, which is to prove that j minus n of x plus jn of x equal to 0 for odd values of n. So solution. So this is one of my favorites, actually, maybe because I've done the hard work, but it's pretty easy, and in less than 2 minutes you should be able to find the solution. Now this is why I say it is very easy. Now proof has already shown us that for j minus n over x, we can still call it minus 1 raised to the power of n j n of x. Now for the purpose of time, I'm not going to show you in this particular video how this still became this, but in the next video I promise to explain it for those of you who are interested in watching. But in an exam scenario, in a test scenario, you should know that j minus n of x stands for the negative order, negative n order. It's still the same thing as minus 1 raised to the power of n j n of x. Is that okay? So when you have it like this, you can now use in your equation. So therefore j minus n of x plus j n of x becomes minus 1 to the n j n of x plus j n of x. Okay, so we now have equal to, if you factor out j n of x, you will have minus 1 to the n plus 1 everything on j n of x. Now you should now take note of these points. Okay, so for n equal to odd numbers, that's 1, 3, 5, 7, 9, and so on and so forth. Okay, to r plus 1 odd numbers, and so on and so forth. So r plus 1 is the formula for odd numbers. Remember, odd numbers is summation r equal to 0 infinity to r plus 1. Okay, that's the first or the list of the odd number. So you discover that whenever n is any of this particular set of odd numbers, minus 1 raised to the power of n will simply translate to minus 1. For instance, minus 1 raised to the power of 1 is still minus 1. Minus 1 raised to the power of 3 is minus 1. Minus 1 raised to the power of 5 is minus 1, and so on and so forth, and so on and so forth. Now, you now discover that, are we together? When we simplify this, we're going to get that j, let me write it again, negative n of x plus j n of x, which is now equal to this. That we can now replace this one with minus 1 plus 1 j n of x, and this is 0 dot j n of x, which is still the same thing as 0. Is that okay? Okay, so this is the proof. So the reason why it is 0 is because for odd values of n, whenever n is an odd number, minus 1 raised to the power of n is minus 1. So instead of me to write minus 1 raised to the power of n, so for odd numbers I will just replace it with what? Minus 1 plus 1, which is 0. And this only holds, okay, for the set of odd numbers. N belongs to r plus 1. That's the set of odd numbers. That's we have 1, 3, 5, 7, and so on and so forth. So this is the proof. Okay, I hope this one was easy. Now what if we are actually generalizing? If it's in the, I'm done with this question, but I'm just trying to generalize. We got that j minus n of x plus j n of x is minus 1 raised to the power of n plus 1 and j n of x. So for odd numbers, this will be 0. Okay, n equal to 1, 3, 5, 7, 9. But for even numbers, this is going to translate to 2 j n of x. Okay, when n is the likes of 2, 4, 6, 8, and so on and so forth. So when n is an even number, you will have that minus 1 raised to the power of even number will be 1. So 1 plus 1 will be what? 2, and 2j n of x. So this is the case for even numbers. This is the case for odd numbers. Okay, so this is the end of this particular video. In the next video, I'm going to show us why j minus n of x is equal to minus 1 j n of x. So I hope you like this video. Subscribe to my channel and hit the notification bell to stay updated. So till then, stay blessed. Bye.